Hi and hello everyone. I am very happy to see you back in this video. Today we are going to see grade 10 first chapter real numbers. Okay, real numbers which you have learnt already in lower classes, right? Natural numbers, whole numbers, integers, rational numbers, irrational numbers, every numbers are called real numbers. Okay, the symbol of real number is capital R. The symbol of real number is capital R. In this, we are going to see the first exercise. In this video, we are going to see the first exercise. In that, only 4 points we have to remember. One is FTA, which means the fundamental theorem of arithmetic. Another one is HCF, LCM, and one formula HCF into LCM is equal to product of two numbers. Right? FTA is fundamental theorem of arithmetic. It explained as every composite number can be expressed in the product of primes. Every composite number can be expressed in the product of primes. You can say any number, composite number. For example, if it is 6, we can write it as 2 into 3, right? 2 3s are 6. So, that is 6 is a prime number, 2 and 3 are 6 is a composite number, 2 and 3 are prime numbers. So, this composite number can be expressed in the product of primes. Say I have written some composite numbers here. So we have to express each numbers as product of primes. Okay. And the second one is HCF, LCM, and HCF into LCM is equal to product of two numbers. In each and every sums we will explain that. See, first sum is 140. So, we have to express the number in product of primes, okay. So, 140, you all know already the division, basic division, it is an even number. So, definitely it will be divisible by 2, okay. So, 7 2s are 14 and the 0. Again, 70 is also an even number. So, we can divide by 2. So, 3 2s are 6, remaining 1. So, 5 2s are 35, 2s are 70 and it is an odd number but ends with 5. So, it will be divisible by 5. So, 5. So, 7 5s are 35. Again, 7 is a prime number. So, we are writing that as 7 1s are 7. So, 140 is a prime number that can be expressed as 2 into 5 into 7, which means 2 square into 5 into 7. So, 140 is a composite number. We can express it as a product of primes. This is how we have to solve the another sum. The all sum which is in your book. So, look at this 156. It is a prime number. What table can we choose? 2. So, 2, how many 2s are? 7 2s are and 8 2s are, right? 78 2s are 156. Again, 2 because it is an even number. So, 39. Again, it ends with 9. So, it is not a even number, prime number. So, using divisibility rules, if we check, it will come in 3 table. So, 1 3 is 3, 3 3s are 9. Again, 13 is a prime number, so we cannot go with another table. So, 13 1s are 13, right? So, 156 can be expressed as 2 into 2 into 3 into 13. So, how can we express in exponents? 2 square into 3 into 13. So, that's all the answer. Very simple, right? Now, can we solve this sum? 3825. Big number. Yes. So, it ends with 5. Definitely, it will be divisible by 5. So, how many 5s are? So, let's choose 5. How many 5s are? 7 5s are 35. Remaining 3. So, 6 5s are 30 and remaining 2 5. Again, it is ending with 5. So, again, we are choosing the 5 table. 1 5 is 5. Remaining 2. 5 5s are 25. Remaining 1 3 5s are. Right? Now it is 15, 3. So let me check that third table. So third table, 5 3s are 15 and 1 3 is 5. Again 5 plus 1 is 6. Again it will come in 3 table. So we can write 3 table. 1 3 is 3, remaining to 7. 17 is a prime number. So we cannot go with another table. We are ending here. So 3, 8, 2, 5. How can we express dears? 5 into 5 into 3 into 3 into 17. So it can be expressed in the exponents of 5 is 2 times, so 5 square into 3 is 2 times, it is square, 3 square into 17. Right? Similarly, let's move to the next sum. 5005. 5005. Now tell me again, it is ending with a 5. Which table we have to go with? Yes, 5 table. 1 5 is 5. 0 0 1 5 is 5. Are you thinking 1001 is a prime number? No. So 1001 we can divide by 7. Yes. 1 7 is 7. Remaining 3 4 7s are 28. Remaining 2 3 7s are. Now it is 143. So definitely 3 plus 1 is 4. Definitely it will come in 11 table. So 11. 1 11 is 11 and 3 11s are 33. Right? Again 13 is a prime number. So we cannot go with another table. How can we express 5005? How can we express? Yes, very good. 5 into 7 into 11 into 13. So no repetition in the primes. So we cannot write in exponents. So 5005 can be expressed as 5 into 7 into 11 into 13. Okay. The last sum of a first Roman is 7429, right? And this last sum is 7429. So it will not come in 2 table, 3 table, 5 table, 9 table. All the test of divisibility rules we can check. We can go with the prime numbers. So first prime number I am trying 17. So if I trying 17, I have worked out here, which is 437. 17s are 7429, and I am moving the 23 table. Okay, 23 table, 19 23s are 437, and again 19 also a prime number. So we can write it as 7429 is equal to 17 into 23 into 19. Right? So the first Roman is over. Next sum. Hi. And the second sum is find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. So before that, I want to explain the next three keys. Okay. Second one is HCF is equal to product of smallest power of each common factor. Okay. Product of smallest power of each common factor. LCM is product of greatest power of each factor. Okay. For example, I will take two numbers which is 24 and 36. For example, if we take, okay, let's prime factorize it. 24 if we do it, 2, 12, 2, 6, 2, 3, again 3, 1. So it can be written as 2 cube into 3. Am I right? Yes. Similarly, 36 we can divide 2, 18, 2, 9, 3, 3, 3, 1. So 36 can be expressed 2 square into 3 square, right? So now see, HCF is equal to product of smallest power of each common factor. Product of smallest power of each common factor. Let us see the HCF. What is the common factor here? 2 is also a common factor. 3 is also a common factor, right? So we can write the both, and we have to choose the smallest power. Okay, 2 cube, 2 square, which is the smallest power? Square is the smallest power, right? So 2 square into, this is also common factor, which is the smallest power? 3 power 1 or 3 power 2? 3 power 1 is the smallest power, let it be. Now 2 square is 4 into 3 is equal to 12. Okay, so HCF is nothing that product of smallest power. Okay, smallest power of each common factor. Each common factor. Only we have to choose the common factors, not the remaining factors. Suppose if I want to find LCM for this, so how can I choose? Each factor I have to choose, and the common factor I have to choose only the greatest power. So only we have common factors, which is 2 and 3 product. Which is the greatest power? 3 is the greatest power. Here 2 is the greatest power. Right? So 2 cube is 8 and 3 square is 9. 8 nines are 72 is the LCM. So the key is the HCF if you want to find product of smallest power of each common factor. LCM if you want to find product of greatest power of each factor involved in the numbers. Suppose for example I am telling, if we have 5 a product here. Okay, so we have to take this 5 also here. No, 5 is not here, so we should not choose. Not like that. Whatever the number is involved, we have to choose. Understand? Yes. Let's move to the book sum. So, in using this, we have 3 sums. First sum is 26 into and 91. 26 and 91. Okay. 26. How can we see? There are many methods to find it. Okay. So now I am teaching you this method. See, which table it will come? 13 table, right? So 13 table. 2 13s are 26 and 7 13s are 91, right? Is there any other common factor? No. So we will stop it. That's it. What is the HCF here? 13 is the HCF. 13 is the HCF. And we have to find LCM, right? For LCM, whatever the factors involved, we have to choose everything, right? So 13 into 2 into 7. So if we multiply 2 sevens are 14, 14 13s are 182, right? So find the HCF and LCM. Did we find the both? Yes. HCF is 13 and LCM is 182. And one more they have told, and verify that LCM into HCF is equal to product of two numbers. LCM into HCF is equal to product of two numbers. That we have mentioned already. It is a key formula. Yes, we can verify. How can we verify? Verification. You have to mention verification. Right? So, how can we verify? First one is formula LCM into HCF. LCM into HCF, right? So, what is LCM here? What is LCM? 182 is LCM and HCF is 13. So, if we multiply 2386, right? 13s are, yes, 2386 is the answer, right? And product of two numbers is nothing that product of two numbers, the number which we have, which is in the question, right? That given numbers 26 and 91. So you just multiply and check it. So it is also 2386. So both LHS and RHS are equal. LHS is equal to RHS. Therefore, It's verified. Understand? So what we have to do? So first we have written the question. We have found what is LCM, what is HCF, and how to verify. Write the formula. LCM into HCF is equal to product of two numbers. You write it and then take left hand side first, work out one answer you will get, and take the second right hand side and multiply that, you will get the answer. If both the answer is correct, it is verified. Understand? Yes, let's solve the second sum. If you want to do it, just pause and you can copy. Now the second sum is 510 and 92. 510 and 92. Okay, let's check it. Okay, the next sum is 510 and 92. Here also we are going to find the HCF and LCM. 510, 92. As usual, what is the common factor for the both? That have to be taken. Okay, let me take 2 because both are even numbers. So 2 2s are 4. Remaining one, 5 2s are 10, 5 2s are 10, right? Here 46. Is there any other common factor? No. Then we will stop here and 2 into, HCF is equal to 2. LCM is equal to 255 into 46 into 2. So if you multiply it is 92, 92 into 255 is 12, 2, 3, 4, 6, 0. Yes, this 510. So 2, 3, 4, 6, 0 is answer, right? HCF. You can multiply and check it. How to verify? Tell me how to verify. Verification you have to write. Yes, verification formula we have to write. HCF into LCM is equal to product of two numbers. Very good. Next, what can we do? What is LCM? Left hand side we will take. Left hand side. Okay. So left hand side is equal to HCF is 2 and LCM is 23460. So if we multiply that 46920, right? 920, right? Yes. Next one, product of two numbers RHS is equal to product of two numbers. What is the given numbers? 510 into 92. So if we multiply 51 into 92 also 46920. Okay. So LHS is equal to RHS, hence verified. Hence verified. This is how we have to submit the answer. Right? If you do like this, definitely no teacher will give your marks. If you do it like this, proper steps, so you can score a good marks, right? Next one, third sum we will do. Third sum. And the third sum is 336 and 54. So you may feel we are going very faster. If you want it, if you want to copy it, you just pass it and you can copy, right? Yeah. 336, 54, right? So both are even numbers. What number has to be taken? 2, right? 1 2 is 2. Remaining one 6 2s are 12. Remaining one 8 2s are 16. Here 27. Now it is 1 odd and 1 even, right? So let me check 3 table. 7 plus 8, 15. So 3 table it will come. This is also will come in 3 table. So 3, 5 3s are 15. Remaining one 6 3s are 18. 9. Right? So 56 and 9. It will not come in 7 8s or it will come, but 9 will not come, right? So no common factors. So HCF is equal to 2 into 3. That's it. If there is no common factor, we will stop and take the factor which is in the left hand side alone. Right? If LCM, we have to take all the factors. 2 into 3 into 56 into 9. Very good. 2 3s are 6. And this is 2 into 3 into 56 into 9, right? So it may be around 3024, I think. Yes. So LCM is 3024. Right? Okay. Now verification. What to be done next? Verification. So verification, how can we write? So left hand side I have to take, which is LCM into HCF, right? LCM is 3024 and HCF is 6. So we have to multiply this. So 4 6 are 24, remaining 2, 12, 14, 14, 18. Right? 18144. Right? Next, we have to write RHS. So 336 into 54. So if you multiply the third sum, find the LCM and HCF of the following integers by applying prime factorization method. What we have done in the first sum, right? So using that we have to find the LCM and HCF. The first sum I have written here, right? Let's find 12. Let's do the prime factorization for each number. 2, 6, again 2, 3, again 3, 1, right? So 12 can be written as 2 into 3 into 2. 2 into 2 into 3, right? Next 15. 15, how can we divide? 3, 5, again 5, 1, that's it. So 15 can be written as 3 into 5. Okay, and the third one, 21. So 3 7s are, 7 is also a prime number. So 21 can be written as 7 into 3, right? So we have written in a prime factorization method. Using that, how can we find HCF and LCM? See, we have taught you already, HCF is equal to smallest power of each common factor. So we have to check what is the common factor for all the three numbers. Not 2 or anyone, no common factor, not like that. For all the three numbers, what is the common factor? See, every number has 3, right? So HCF is 3. And how to find LCM? LCM is nothing but greatest product of greatest power of each number involved in that, right? So we have to write first 3 common factors. What is the common for all the 3? 3. Is there any common factor for 2 numbers? No. And we have to write the remaining factors. So what are the remaining factors? 2 into 2, here 5 and 7. So if you multiply, 5 2s are 10, 7 3s are 21, 42, so 420, right? So HCF is 3, LCM is 420. That's it. That's all. Find the HCF and LCM of the following integers by applying prime factorization method. First we have to prime factorize it and then we have to find the common factors for all the 3 numbers. So that is HCF and LCM is the factors involved in that numbers. Let's do the second sum. Second sum is 17, 23, 29. Look, all are prime numbers. If we do prime factorization, what will we get? Nothing, right? 23, same 23. No other number, right? 29 also, same 29. So we will get the same number only, right? So if you write only prime or composite numbers can be written as product of primes, right? So already it is a prime number. So how can we write this? 17 into 1 and 23 can be written as 23 into 1 and 29 can be written as 29 into 1. Since there is no common factor, 1 is a HCF. HCF is equal to 1 and LCM is equal to product of all involved factors, right? So 17 into 23 into 29. If we multiply with 1 also the same number. So if we multiply that, the answer is 11330. Right? So HCF is 1, LCM is 11,330. Right? Next, third sum, 8, 9, 25. Right? So 8, 9, 25. Let's do it. 8, 9, 25. Right? Third sum. Okay, let's do prime factorization for 8. How can we divide it? 4 2s are again 2, 2, 2, 1. Right? So 8 can be written as 2 into 2 into 2. Similarly, 9. So 3 into 3. Right? So 9 can be written as 3 into 3 into, that's it, 3 into 3. 25. Same 5, 5, both are prime numbers. So 25 can be written as 5 into 5. Right? Okay. Now we have to find HCF and LCM of these two numbers. What are the common factor for every numbers? There is no common factor since last time it is a prime number. Right? So it has no common factors, it has no other factors, but here all are composite numbers, but there is no common factors, right? So 2 only here, 3 only here and 5 only here. Since there is no common factor, every number has a product as 1. So HCF is 1 and LCM is equal to same all the factors 8 into 9 into 25. Okay. So 8 9s are 200. So 1800. So the HCF is 1 and the LCM is 1800. Right? Yes. So next fourth sum. So I think the video is going to very length. So let's stop here and we will see in the next video very soon. Next 4 sums I think. In exercise 1.1 there are 7 sums. Already we have done 3 sums. Remaining 4 sums we will check it in the next video. Thank you so much. Make sure to subscribe if you want to crush the board exam. Give a like and share to your friends, those who are in really need. Let's make together math simple. Thank you.